everyone, and welcome back to the Information Bottleneck. And today we are going to talk about many topics, but we'll focus more on evaluation and also on how you evaluate and actually how you use computer agents. Um, so today, first of all, hi Alan, welcome back.
Always happy to be here, and this time coming here from iClear.
And today we are hosting Wenhu Chen. He's a researcher at MSL at Meta and assistant professor at Waterloo. Before that, he was at Gemini team at Google. Hi, Hinu.
Hi, Ravid and Alan. Thanks for inviting me. Yeah, I'm super glad to discuss some of the research insight with everybody.
Thanks for coming. So I think let's start with evaluation, or like what we can say about how to evaluate recent models. And I think this is a huge discussion, right? Like we hosted and like we talked about it in the podcast a lot in the past. How do you see it? How do you see what does it mean good evaluation? And how far are we from good evaluation process?
Yeah, I think evaluation has evolved throughout these years, right? So back in when I entered this field in like 2021, 2022, we had like GPT, right? And very early version of GPT and Gemini. And evaluation was relatively easy to build, right? Basically because the model capabilities are not so good, right? So you basically just build like uh benchmarks that human can do, right? Well, the models cannot do. And so that's why like we build a lot of the benchmarks for like exams, right? Like humans exams, and or different type of tests, right? Like AIME, that different like challenges, right? And then you just assume these would be like good evaluation benchmarks because they are the things that humans can do while the models cannot do. And then they also require like minimum like context, right? Basically, the problem itself, like with hundreds of tokens, is all you need to solve it, right? And so that has been like the principles of like building benchmark in the past few years. But recently it has evolved so much that like the models have been saturating on these like common benchmarks, and the models' capabilities are arguably like better than humans. So now like building benchmarks are much more challenging, right? And one thing I've been thinking about is uh, uh, there are different benchmarks, right? So you need benchmarks for uh, a lot of scenarios. You need benchmarks like for pre-training. You need like benchmarks for post-training, and then you also need like benchmarks for like kind of agentic evaluations, and then also safety, right? So they all like adopt different principles, right? So yeah.
But I just want to go step back a bit. Like let's start with like why we actually care about benchmarks. Why we actually want to, like, or what does it mean good evaluation, right? Like for you.
Yeah, I think uh, evaluation is very important in a sense that they can give us like very good signal, right? And then tell us where we should do, right? So like models have like gradient descent, right? Humans or human researchers also have like this gradient descent, right? Like because we have a lot of great engineers and scientists, like especially like big companies like OpenAI and Anthropic, Meta, whatever. They're really, really good, like hill climbing benchmarks. Like I can pretty safely say that if you come up with some benchmark, and then like these brilliant people, they're gonna tackle it like in maybe a few months, right? So benchmark, like how do you design benchmark will be very important because like uh, it's basically like a way to guide these people and then try to tell them like what to optimize, right? It's just like your uh, loss function, right? For gradient descent, if you have a bad loss function, right, so you are climbing a wrong thing, right? So that's why your benchmark It's kind of like this loss function that can provide people like a lot of signals in terms of like where to go for, and then it has to have like a good correlation with a lot of things. Like one is like it has to correlate with the model's real capability instead of like its capability to overfit, right? And then it also needs to correlate with maybe some real world values, right? So that's why we have like GDP values and like remote uh, labor index. They kind of measure the economic values of each specific evaluation tasks, right? So, and then you can very clearly measure and calibrate like what specific values these tasks are.
Oh, and I just have a quick question. I see these the benchmarks. Everybody's like concerned right now about benchmark contamination, and what I worry about are you don't even try to be training on the test set, but because the data was posted online somewhere, you accidentally scrape the test set data, even if it wasn't on purpose. This seems like a pretty big problem right now. Do you know of like what we can do beyond just never posting the test set on the internet ever to kind of reduce this risk?
Yeah, I think this has been very big issue, right? So, like a lot of the times, we so at the model trainers, they just accidentally, access some information from the internet and then train the model, and then somehow they have like a lot of like overlap with the models, with the benchmarks, like prompt or whatever, right? Like I think one famous example is like ClawBench. All right, like a lot of the questions are regarding like the pull request, right? So the model can, like if you just train on GitHub, right, you like unpurposefully, just download all these like Git pools, and then they somehow like correlate very strongly with this benchmark. I think this has been a big issue, and I think like the best way is like like as a model provider or at this frontier labs, you really need to do like decontamination very carefully and very rigorously to to make sure that like your training data, especially like your post training data, has like enough like uh, uh, distance from these benchmarks, right? And also, as you mentioned, other benchmark hosts try to like hide these benchmarks. But this, I don't think that's like the best approach, right? Because it's still sourced from the internet, right? And people are still gonna contaminate it without actually knowing it, right? So I don't think that's like the best approach. It's just making things less transparent.
So, but how so you invented the MMMU and MMLU-Pro, and like so, and everyone are reporting these numbers now, right? Every frontier lab. And when you look at these scores on those benchmarks today versus when you release them, how much of the headline progress like reflect real capabilities versus just data contamination and training on the test distribution?
Yeah, I think models are still making a lot of progress. I think like when we started these benchmarks, models are probably getting like 30%, like 40%. Right now, they are mostly around like 90%. So there's been roughly, like 60% or 50% like increase throughout these years. I think like only looking into like one benchmark doesn't make sense because, because it's just like one data point, right? So it's better to like look like broadly into, a set of benchmark, and then, from this, very broad like set of evaluation, I can safely say that like these models are really getting a lot of progress, right? So as a user ourselves, right, we've been interacting with them, and we can feel that there's been tremendous progress made throughout these years. I think these benchmarks are still kind of valid, and they have been, reflecting the progress that we have made throughout these years. But right now, I think they are at the point of like saturation. So they might be a good unit test type of thing. just to tell you that, if your model is already getting like 85%, like 87%, it basically means that, your model is good enough and saturated on this benchmark. And it's a good like unit test. And now like you should go after other benchmarks, like more difficult benchmarks and or advanced benchmarks or agentic benchmarks. And then like on these like, knowledge type of things, you don't need to worry about it, right? But if your model hasn't like reached like 85% or like 87%, it probably means that there are some like still some gap in your training, either like in pre-training or post-training. You probably didn't capture some of the knowledge or some of the reasoning patterns, and it's like checklist right now. So people still, when they are like training their new models from scratch, they still need to check like MMLU, MMMU, like reaching this level, and then gonna pursue, next target like HLE or like browse count, that kind of things.
So, how would you evaluate creativity? Quality seems to be the primary thing, or like, rate of completion, especially for code generation that your work has touched on. I, at least in my papers and papers with reviewed, we evaluate creativity, but it's really hard. Still don't really understand how to do it. Do you have opinions?
Yeah, I think like when people try like some rubric based approach or LLM as judge, but those are very very difficult. Like they might be able to like provide you with some like shallow uh, metric in terms like some correlation with some engrams, right? Those sounds like creative, but not like truly like measure the creativity of the output. I from my point of view, I think the best way to do is like through like A/B testing. You can just like if you are like model provider, right? You can roll out these models, and then you can encourage people to use it like creatively, and then you can use some like user metric, right, on like during their chat, to actually give some insights, right? For example, like how many rounds they interact with the model, and the sentiment of their responses and something like that. Those will be like more valuable, like live metric to evaluate like creativity.
So maybe let's go to agentic agentic benchmark. So like few weeks ago, we talked with Anastasius, the co-founder of RM Arena, and he basically said like the only thing that like we can do is to ask users, right? Like basically RM Arena, right? Like let's give the users play with these models, and this is the best way to evaluate our models, no data contamination, right? All these problems. But Chief, you have different, like you basically suggest like different path, right? Like let's move from static benchmarks, right? Everything is clean. The input, the output is curved to agentic benchmarks. That the like these models, right? Like when models can do 1,000 step trajectories on live websites. Let's start to decompose it. Like, what does it even mean, ground truth in this case?
Yeah, that's a pretty interesting topic. So I think you raised like 2 points, right? One is like the LM arena thing where the founder they trust that like human feedback will be the the most valuable metric to evaluate the model. I feel like this is not quite the case from my experience. So I think human judge is like very it's actually very unreliable, so especially like from just the general model users, they tend to be like impatient and not quite serious about the evaluation because they're not like earning money or anything from this process, right? They are highly influenced by like styles and lengths, and this kind of things or tones, right? And this very shallow things instead of the content, right? So if you want to evaluate the model's capability, right? So you really need to pick the really, really hard prompt and the prompt that the model has not seen during the entire training and try to to evaluate its generalization. From my perspective, I think there are a lot of like very good use cases for for models, like for evaluating models. Like there are lots of like sectors where we have like zero data about. Like for example, we evaluate the models on Meta's code base, right? And obviously the model hasn't seen any of this because this is like highly private information, right? And then you can also evaluate it on like some hospitals data, right? Like patients data. These are not the kind of data you can actually crawl from the internet, right? So if you go to different like industries, there are tons of like private scenarios where the models has never been exposed to, and then those are like really good, like all the evaluation setup from my experience.
But why we actually like maybe it's go back to the previous question like that we start with like why like this is the most important part like why like you talked about audio like you think that like we didn't see before but like actually like if we can I don't know simulate like have a lot of examples maybe we don't care about things that like we never seen before why we should like just try to train the model like to evaluate the model on all the possible scenarios or most of them right the interesting ones.
Yeah. Let me try to clarify this question. So you basically are saying that like contamination is not a big issue because it's like those are the cases that users care about, right? So
Yeah.
and yeah, I think generally so there are like two levels of problems. Like one is like the benchmark is a way to measure progress, right? To compare different models, and then if like everybody contaminated, and then it loses its own purpose of being an indicator or a judge, because like a model can be like intrinsically less powerful than B model, but like A model contaminated more, right? So it gets better performance on the benchmark, and then the benchmark suggests that like A is a better model than B. This will have like provide a lot of like misleading information for like the model users, right? So like these models have been deployed on a lot of places, like in government, even like military or whatever, right? So the decision in terms like which model to use can be very impactful and have like a lot of long-lasting impact in terms of like it's like it's like impact on different things, right? Uh, and that's why we need a very clean sheet, right? A very good indicator to give us some idea about like how this model is actually in terms of its capability and also in terms of its generalization instead of just like how contaminated it is regarding these benchmarks.
And you brought up like military just now. There's actually a workshop here called AI for Peace, and I'm wondering if you have opinions on like what people in I guess the community of people who dissent against war and war fighting and other traditionally I would call it like progressive movements. Like, do you think that there's any role for people making data sets to kind of try to find ways to like access gate some of this stuff, or at least to try to prevent those who might want to use the use cases that somebody who released a data set might not agree with from using? Or what do you think about this?
Yeah, I think AI should be like used for the public like interest, right? Instead of like for military purposes. I think that yeah, we so one way we can do is like we try to like use less data regarding these purposes to make sure the models are pretty weak at this area. So they like once they deploy it, they realize these models are not reliable. So they just give up, right? So that would be one solution. Yeah. But other than that, I don't have too much like opinions. Yeah.
So I want to say okay so we understood that like there are problems but what do you think how like a good benchmarks looks like? Like, what are the axes that you want to test? How you like manage it? Like what you actually measure.
Yeah, I think like a good benchmark. I don't think there is like a permanently good benchmark, right? So benchmark needs to also evolve, right, as the model evolves, right? So uh, as like a benchmark maintainer. So you probably need to like have like V1, V2, V3, and V5, 4, 5, to keep track of the model's development, right? But like in within each version, I think there are like lots of principles to to judge whether benchmark is good. Like one is like the diversity, right? Whether it kind of covers enough scenarios, and whether these tasks, embedded in the benchmarks are like valuable, right? So that's also something that I mentioned before. Does it have like true like economic values? Does it really like reflect the kind of tasks that we care about, right, in our workforce, right? So does it actually contribute to the society? And then that's the second one, right? So the third one is that benchmark needs to be clean, right? So I understand like some of the metrics can be very noisy, right? So we need to make sure that the metrics are like less hackable, right? They need to measure how really good the model is instead of it just like being hacked throughout this like RL process, right?
Do you think we also like should measure the intermediate results? That like I don't know. Does it matter whether the agent took a sensible path or only like whether the booking got made, right?
Hmm, hmm, hmm. Yeah, I think so. Yeah, it's just that like the intermediate results have been very difficult to measure, so people kind of give up. And like I do think like just like by like viewing the trajectory of the model could be a very good indicator. So if like maybe like two models getting the same type of accuracy or like a correct output, the wrong ones, like one is, more persistent, right? One is more exploratory, right? The other is like give up like very quickly, right? So I think like the model that is more persistent will be better, right? So this will be like very useful signal to provide to the model developer when they're training the models. So, but just that we don't have like a very good common consensus in terms of like how we actually measure the intermediate results. So there are like some like rubrics that we can come up with, but they are pretty like hackable. you know, yeah.
And what do you think about chain of thought as a measure? There is a huge debate if it's actually like useful for something. Do you believe that it is?
I personally think that like chain of thought is very, very important. So there has been a lot of papers suggesting, we've seen a lot of progress, right? Like after like '01, where people try to, increase the length of the chain of thought process, and then the model gets much, much better performance, both on benchmark and also through our experience of interacting with these models. I think like the chain of thought itself, right? So the content within the chain of thought might not be that useful, right? And what it actually provides is like it's like a scratchpad or something, right? For the model to actually spend its compute and then trying to like spend more tokens and then try to like maximize its computation process, right? But like what's actually written in the chain of thought might not be that valuable for us to provide like a metric or a judgment or anything. So that would be my thought.
And what about, like, do you have opinions about different types of test time scaling? There was chain of thought, and then there's tree of thought, and then there's approaches that try to do like computational, like debate. Pretty much the entire library called DSpy kind of specializes in integrating these methods. So, do you have opinions on what's good or what's not within this?
Uh, Yeah, I think these kind it's I think they're way more than this. They're like also like graph of thoughts, and there are also others as well. Like I think these are just ways that people try to build like priors into this thinking process, right? So and chain of thought is like the most like loose format where people just linearize everything, right? And then hoping that like through this linear rollout, the model can kind of capture everything. Like tree of thought, it's kind of meant to enforce a prior that like this reasoning is through a tree process, right? It's a tree, right? So you can backtrack and something like that. You can basically add this kind of prior to it. And there's also graph where you can kind of like enforce more constraint into the uh, thinking process. I would say like chain of thought itself, right? This linear process. I think it's most generic approach, right? And like for tree of thought and graph of thought, we haven't seen its like wide adoption in the community, right? It might be like pretty useful in specific scenario. For example, you're like solving a puzzle or maybe something like that, or solving some games. You can bake in this kind of structure to make your thought process more aligned with the nature of your use case. But like just in general, I think like chain of thought might be the easiest one and to kind of help people like scale things up.
About auto research, since Karpati's past, like kind of 2 months ago, everyone talking about like how you can um, follow the signal, climbing the hill of some very specific. If you have a specific problem or like some benchmark, just let the agent to iterate over it and find the right hyperparameters and the right architecture or components. And I think like we got some mixed results. There are several people that found that like it works, and some of them found that it doesn't work, like in more general scenarios. What's your thoughts about it?
Yeah, I think
Do you
this.
think,
Yeah.
and also like, do you think like this is a good way to evaluate models and agents?
Yes. Yeah, I think there are like two levels of the problems. One is um, if we have good signals, right, then the model can do auto research very well. I've been like using it quite well, quite often in my like research process. But the entire thing uh, and the entire thing is built on top of like a trustworthy signal, right? So in order for this like self iteration to actually work, you need to have a like very good signal. Like so that boils down into evaluation, right? So like in this like queue climbing process, you need to design a very trustworthy goal or very trustworthy metric for the model to queue climb, and the model can do a lot of things, just like human researchers, right? They can explore the archive and read all these like fancy algorithms and try to implement it and hill climb it, right? So I think as long as we have a very good metric there, the agent can do fairly well. That's like one level of the problem where we need like good evaluation for the model to hill climb. But on the other hand, like this whole process is also a good way to measure the model's capability, like the agent capability, right? For example, if you fix the prompt and fix, the evaluation metric, and then you compare like different agent models or agent harness and see like how much they can hill climb, right? And then this gives us a very good way of like uh, in terms of evaluating the model's capability, especially like the exploratory capability. And then also gives us a way to evaluate like how good the harness is, right? Like how good the agent framework is.
And
And for these agent harnesses, do you have opinions right now on, for example, beyond like context compactification, what separates them and makes them good or competitive with each other?
Yeah, I think agent harness is very, very important right now. So I think like before OpenClaw, right, uh, people know like that there's Claw code, which is really good, like agent harness, and but it's like not open sourced, right? So people don't actually know like what's actually going on in the Claw code and what are the tool sets and how these processes are like orchestrated. But like the open cloud came out, and then there's also linkage of like cloud code, right? People realize that like the harness is just as important as the model capability itself. So from my point of view, I think the harness needs to, co-evolve with the model, right? So, um, like I think a lot of people have conducted like experiment with like the same model, but like if you use like different harness, and then you get like tremendous different results on like some of the popular benchmarks, like terminal bench. If you switch to another like harness, you can, probably if you get things right, you can probably get like 20% improvement. Which is huge, right? Sometimes you train a much larger model and you won't get like 20% improvement.
But do you think like then the harnesses are like they supposed to like the role of them will be they will be more important, right? Because like I would expect that like if we have better model, they will understand how to work with different environments, right? So do you think this will be the case, or like at the end we need very specific environment and very specific setting of I don't know tools and like and the pipeline in order to make these models work in specific
Yeah,
cases?
yeah, that's a very good question. I do think that like if you have like an AGI model, so probably it doesn't matter like which harness you are using, right? So it will just adapt and then solve everything. But like by the time we arrive like AGI, harness is still important, and then harness is also uh, a very good way for us to like understand what the models are good at and what other models bad at, right? So we need to like design things very carefully, right? So if the model is like pretty bad, like exploration or something, right? And then you probably need to enforce like a way to, to ask the model to help the model like explore, right? Try to use more search function or try to like have like specific like tools that to help guide the model explore, right? If the model is pretty reluctant, and then you probably need to like implement like sub agents, right? Kind of help it like parallelize things. And I do think like harness is very important when you are shaping a model, right? For example, if you are like at Meta or at like OpenAI, you know pretty well like your model's like personality or like weaknesses and strengths, right? So you can uh, cater your harness design towards that to maximize, the power of your model.
And then do you think that they will compete in the future, especially in a post AGI world, on safety and alignment? Because I mean, if we ever had like a real, or I prefer the term ASI, right, for super intelligence, it seems very dangerous to put in the hands of most people.
Yeah. So you meant like a competition for what?
Like I don't know, for example, even Mythos, right? Like a model slightly better than the latest Opus, they're already saying, hey, we can't release that to the public because of, it's finding security vulnerabilities. And then they always do analysis trying to minimize risk of people creating like bioweapons, right? So I'm just curious, like, and I guess even further, it's like it seems like you do believe in the bitter lesson, right? Could you answer on that if you do or not?
Yeah, yeah, I do believe on Peter lesson. I feel like yeah, safety is a very important area when like the model builders need to consider. So yeah, I think moving forward, like measles is just like one example, right? So I don't think they figure out like how to release the model right now. I think it's like a very big model that's very powerful, and then if you just release it to like some bad guys, right, they're going to use it to create a lot of harm to the society. I think maybe like later we need to have some sort of like uh, or membership or something like that, where people like like in the airport, right? People do have like the clearance, right? And then maybe like in the future, people will do like background check and then they're gonna be security screened, and then after all this checks, they can use these models while the people who didn't pass this exams or screening or like it could also be associated with their like credit score or their like criminal history or something like that, right? And then like in terms like what kind of models they can use, if if that's one of so that's just some random thought.
Like a social credit score, right?
Yeah, something like that, right? Yeah.
I think you have in China, right? Something like that.
Yeah. Is there something like this implemented in China? I don't know actually. Yeah.
Yeah, but I think like, but also like evaluation is like a very good component here, right? Because like at the end you want to regulate this model, and but you want to regulate some of like the use case of these models, and evaluation is a good way to do it, right? Like now you want to release a model, so like you can give it to the, I don't know, to the FDA, like the version of the FDA that evaluate models, and they will evaluate like the risk and like under which conditions you can actually release it. Do you think this is something make sense, or do you think like we will? It's too hard to evaluate the risk in these models.
Yeah, that's a very, very good uh question. So like when we're building like normal benchmark, right? Uh, so what we want to know is like whether the model, if whether there is a way that the model can uh, solve this problem, right? Uh, and then like from the safety perspective, it's like the other way around, right? So it's like, does there exist a way that the model can solve this problem? If so, right, then don't release it, right? So it's kind of like a different approach. And then you need to like to disprove, right? This you need to like enumerate more broadly. Yeah, it's definitely a much more challenging way, right? So if like if you just give it like some general prompt, like probably won't ask you how to build like bioweapon. But if you have like very strong harness or something like that, maybe they like deal break and then do like make something, yeah, that would be very much more challenging.
So till now we talked about mostly about post training, or like how to evaluate the end capabilities. And you started in saying that we actually need to look on the different training stages, right? The pre-train, mid-train, post-training with different evaluations. So can you elaborate on these
Yeah,
different stages and how we actually can measure it?
yeah. I think evaluation in pre-training is actually more uh, it's like an overlooked thing. I think partly because the general public don't do a lot of pre-training. Academic labs don't do pre-training, and then they so the science of evaluating pre-trained model is like less discovered or less like public. So in pre-training, right, I think that there are like normally people look into two metrics. One is like the NLL, so the negative log likelihood, uh, or the perplexity, right? So that's very different from like these agentic evals or whatever. It's not based on accuracy, and then you don't let the model generate things, and then at the end you like measure its accuracy. You actually give a choice. Or give the correct answer to the model, and then ask it to, go through it and evaluate negative log likelihood, right? And then use that as a metric. And those has been very useful. So I guess like everyone knows like scaling law, right? So there are like this curves, right, where the model like when you increase the flops, right, the curve actually decreases, right? But what's the curve measuring? It's basically the pre-training evaluation, right? So it's like what kind of set you give the model to actually calculate the negative log likelihood, right? So what kind of things you hold out, right? And here things are very very interesting. Like one principle for designing good pre-training benchmarks is that it needs to be like non-contaminated. So it has to like be very very like out of distribution of the pre-training data. So because these pre-training metric like this scaling ladders have been very important in terms of like how you tune the hyperparameters, how you design the like the ratios of different data components, right? So if like your data, if your metric or your like corpus is kind of contaminated towards specific data, right? and then it will correlate very strongly with that type of data, right? For example, if your metric reflects a lot about like OCR, right? And then you will, you basically guide the model to actually choose more PDF data during the pre-training. So this can be very, very biased. And then if you choose your your capacity metric to be, I don't know, like some stamp, right? And then you will guide the pre-training people to select more like books or more like stamp PDFs or whatever. So like how to actually design a good like pre-training corpus to measure the NLL is very important. And then there's also some recent challenges in big labs in terms of like how do you measure the impact of synthetic data, because like synthetic data, if you add it into pre-training, you will see that it drops very significantly on the NLL, or for like some evaluation benchmarks that we created. But it doesn't actually reflect the true capabilities of the model. So
So you said the synthetic data is so the loss on the synthetic data is higher for the in the pre-training, but it doesn't like affect the downstream task, right?
it's kind of complex. I would say, because pre-training is something that you kick off like once in a while, and then it's consuming a lot of uh, resources, right? So it's like if you make a mistake, it's impossible for you to kind of recover. You probably need to spend another like $1 billion to retrain another model. So like what's going to be put in the pre-training data, it's a way more like riskier decision to make. But like post training is fine, right? So people they do like post training a lot, right? But like compared to the resources to the pre training, it's very minimum, right? You find out like adding a lot of synthetic data there gonna give some like detrimental impact on some other like use cases. You just repost train it, right? But like pre training, I think it's more difficult. Like every decision that you make has a very profound impact, right? Because if you don't measure the pre-training progress well, and then like the benchmark pre-training benchmark gives you a wrong signal, and then you select the wrong data set or you choose the wrong architecture, and then you train like a big model like GPT, whatever, right? And then like you consume $1 billion already on that. And then during the post training, you realize that, damn, so the model is broken. The pre training has already done a bad job, and there's no way that you can recover it. Because like and then like in the post training, so it's impossible for you to actually just to like post train a little bit more or whatever to recover, because like the capability is not there, or something is missing. And then the only way that you can do is just by retraining it from scratch or doing some mid training, right? But mid training itself is also very complex because itself gonna you need to consider a lot about like the stochastic catastrophic forgetting, and also like I need to balance different read domains and something like that. So mid training itself is also very difficult. So that's why it's to the original point that designing a good like pre-training benchmarks is very very important, because it has like some profound impact in terms of like the model um, shipping and model delivery.
So what is the solution? How you design it?
Yeah, so I think a lot of people just use their like internal code base or like internal documents or something like that to prevent like overfitting. And then also you need to make sure that like these benchmarks are like high quality enough, right? So actually at a lot of places they do like very rigorous audit of the pre-training corpus to make sure sometimes like they raise the bar of the data quality to be actually higher than post-training data. For example, I think a lot of places like the pre-training benchmark or like the quality is it's actually better than like MMLU-Pro or MMMU, because it's just so important that like you just can't mess up with it.
But do you think so? Like, why it's actually I want to try to push back a bit because like till now, like we saw this like incredible, let's say, correlation, right, between pre-training likelihood, loss likelihood, performance, and downstream tasks, right? Like most of the time, when you have good pre-trained models, you will get at the end. You may need to do a bit tweaks and things like that, but like you will get good models like for post training, right? Like there are not a lot of models that are really powerful pre-training models, and you can't get a good downstream task performance. So if you see this great correlation till now, like why would to bother to try to push in this direction?
So you mean like so sorry, like specifically in which direction?
So why to bother to actually like measure, to spend so much effort on measure pre-training and to do evaluation for
Why?
pre-training if we can at the end, like we know that like yeah we have like if we can get just like a lower loss likelihood, you will get good performance on the same task.
Yeah, I think yeah. So it gets back to so you basically suggesting that like the pre-training benchmark and post-training you can basically share them or something like that. Yeah,
Yeah, for
yeah,
example. Yeah.
yeah. Just goes back to the like the original thing where uh, pre-train post-training is mostly like generative based evaluation models. While pre-training is not like pre-training is like you need to evaluate the generation and based on the negative log likelihood. And the difficulty is like you know in post-training right now, so you have a lot of this very difficult benchmark like HLE or you know, humanities last exams or like ClawBench or whatever. Those are like difficulty maximized, right? If you just use them in the pre-training, you won't see any signal because like when people are doing like science of pre-training, they're plotting the scaling ladders of smaller models. You know, those are less powerful models. They will basically get like zero on like HLE or whatever. So that's why you know the nature of like pre-training is very different because the nature of pre-training is like you need to measure the models like memorization and then knowledge and something like that, and then you don't measure too much about like reasoning and very difficult you know like downstream tasks because you probably won't see much signal there. You know like because like in pre-training we are normally we don't kick off like the very big model training very often, right? So like for example, like GPT-5 or whatever, you're probably gonna just train it like once half a year or something. And most of the time, the pre-training teams are pre-train are doing are like on like very small models, like probably like 1 million, sorry, 1 billion parameter model, or probably just like 100 million parameter models. They're starting things in much more smaller scale, so they can like train from scratch. So that's like a gap here, right? So in the post training where you have like you normally only consider the largest and most powerful models, and you want to maximize the capability on this downstream difficult tasks. But in pre-training, you're mostly dealing with these smaller models, and then you try to use these smaller models, like scaling curve, to extrapolate, right, and then predict how things will be in the larger scale, right? So you need to make sure that benchmarks are highly reflective, that like the scaling curve needs to be very smooth, so things can be more like predictive, right? So if you select a wrong benchmark, right, you're gonna see a lot of fluctuation from like you know 10 million to 20 million to like 100 million and then to 1B, right? And then you won't be able to plot the scaling curve, and then you have no idea like if you train like 100 times larger model how things gonna evolve, so things are like really unpredictable. So that's why you need to consider different type of factors here, right? So you need to make sure that it's not that difficult, and then it kind of like give you enough signal to help you like select the best, you know, hyperparameters and data or whatever to fit it well, right? And then you know make it make some really good prediction about like what's like a 100 times larger model will perform.
Okay, maybe we can talk a bit about agentic computer use and what you think about it. So you recently published a ClawBench, right?
Mhm.
Uh, I think it was like 150 tasks across and 140 live production websites, and like I think like maybe like the strongest models were um really bad. Even the strongest models were really bad. Um, what do you think is the let's say the dominant failure mode? Like what parts is not there yet? Like grounding, planning, recovery.
Yeah, yeah. Yeah, I think this like the best model is around like 33%, which is by like cloud model. But this is like a very big like underestimate of the model. So like it comes back to the challenge of like of like building these highly agentic evaluation benchmark, right? So for us, right, we want the models, we want to evaluate the model's capability on as realistic scenario as possible, right? So which means that we want to evaluate like how well it can order like Uber Eats for me, or it can order a ticket from like Ticketmaster for me, some concerts or whatever. But the but the issue is that like, a lot of these platforms they have like anti-bot mechanisms that right. They have like captchas, they have like Cloudflare to detect your bot, right? And so it's extremely hard for the for us to actually just run the model like agent like automatically on these kind of tasks and gather its performance, right? Because a lot of them are either being blocked by the vendor websites or like that's like one hand of the problem. The other hand of the problem is like the model kind of refrain itself from conducting a lot of these actions. For example, in order to like order Uber Eats, you need to pay, right? So the model realized, like if after this action, I actually need to pay for it. And then the model will refrain itself from like doing it. Just it will just stop there. And then you don't as a benchmark, right? It's pretty bad because you don't actually know whether it's the because the model can do it or the model reject to do it, right? So so that gives us a lot of fluctuation in the score. So like ClawBench is basically like one attempt that uh, uh, we did to actually bridge the gap. So what we ended up doing is like we try to implement a Chrome plugin uh, where we try to hand code a lot of rules for a lot of websites. And then this plugin will detect whether the model is or the agent is trying to make some sort of like big actions, for example, like purchase. Or send something out or post something out or whatever. So we have like these plugins that kind of intercept this HTTP request, and then so that it's kind of safe for us to evaluate because we are sure that the model won't actually send this post request out and to actually make like real world impact to actually deduct money from your bank account or something. And but still it's not it solves like one part of the problem, but the other problem is like like these websites they have a lot of like this bot detection mechanisms. So the bot could a lot of like 33% 33% is what we get, right? So like out of this 60%, I think maybe like half of them are being are due to these platform based like a bot detection mechanism. But it's kind of varies, right? Because like it depends on your account, it depends on your IP, and then if you evaluate it on different clusters or you evaluate with like different IP address, you probably get slightly different results. So it's kind of like very difficult problem to solve. So what we suggest that like the you run it like multiple times and then across different like clusters and then take some average out of it. So to make sure that it's the true estimate of like how well the model can complete these tasks. Yeah.
So I'm curious. You along with trying to kind of improve models, you've improved your benchmarks over time with MMMU or is it MMLU? Sorry, MMMU Pro, for example. What went into creating these Pro variants, and what would be your insights into people with existing data sets that want to refresh them and make them useful again for modern models when they've become saturated?
Yeah, yeah. So I think at that point it was pretty natural decision to make. So like when we released like MMMU, and then also like MMLU was published by like Dan Hendrick, right? So we like on social media platform we heard a lot of complaints about these data sets, right? People are saying that they're either like there some of the the annotations are wrong maybe, or the problems are not difficult enough, right? And sometimes also their coverage is too bad or something like that. We solicit a lot of feedback from the social media, and then it's so much, it's so overwhelming, and then until a point that we realize that we have to build another one. Otherwise, people just won't get away with it, and so we just kind of condense or consolidate from this feedback, like into like some actionable items, right? So like in MMLU, one issue being that like it's full option uh, MCQ, right? People can easily guess it correctly, right? And then like the model getting it correctly doesn't mean that it understands it. So one of principles that we implemented was to like increase to like 10 options. So the random guess correct ratio like lowers from like 25% to 10%, right? It's an attempt. It's not perfect. Still, like the models are still kind of guessing, and it's just that it's less influenced by this kind of random guess factors. That's like one of the things that we implemented to improve LU. And for MMMU, I think one criticism we receive a lot from the public was that like it's a multi-model benchmark, and a lot of questions you need to look at uh, the images actually to answer it when we design it. But like later on, we felt that models are so good that they don't actually need to look at the image to get it correctly. It's like there was a point where like if you ask the best model to solve it, it's like the solve rate is like 50% or something. If you remove all the images, just give the text to the model, it can still get like 40 something percent. So the gap is very small. It's like only like 10% drop. And then you realize, like a lot of the images, they are there, but they are not important for the model, enough for the model to deal with. So that's why we try to upgrade this benchmark to either like we will rewrite some of the new prompt to make sure that the model has to look at the image to answer those kind of questions, and try to enforce the importance of the vision in that benchmark, so that it's actually a multi-model benchmark rather than just another version of MMLU. Yeah, so that's kind of the things that we did. I think moving forward, right? So because like I think one reason that we didn't like push for like Pro or Plus or something like that is basically my students get pretty bored and like doing all these annotation and benchmark things. But I do think there are still like a lot of room for like improving these benchmarks. I think generally just we need to like keep track of the modern models, and then understand their failure cases, and then also solicit a lot of like feedback from like model developers, and then we can like condense them and transform them into actionable items to kind of improve the model. Sorry, to improve the benchmarks. Yeah.
Some very increasingly visible split, like pure vision computer use agents versus agents that bypass the GUI entirely, right? And call some APIs, MCP servers, whatever. Um, What do you think? Like, is pixel level latency a phase where we go through until we have enough softwares that expose APIs, or is it a permanent because the long tail of software will never have MCP servers?
Yeah, I believe it's the latter, uh, case. And I think MCP will be more and more popular, and a lot of the software developers or a lot of the websites, they probably gonna converge or switch to like providing APIs. But I still think that like it's a very long tail thing, right? There are lots of very old, like unmanaged website, but like millions of people are using, right? And so, for example, like DMV or something like that, it has been there for many, many years. I think it's pretty. There are like pushbacks within this organization to kind of to replace the entire software or UI with like MCP APIs. So, go ahead.
Oh, I was just gonna follow up and ask: do you think then, because there's this narrative amongst Wall Street types that there's a software as a service apocalypse happening right now, as systems of record companies like Salesforce, et cetera, move or kind of the pricing. The theory is that the pricing needs to be pay per use instead of pay per seat. So, do you think that we would see taxes on MCPs, so to speak, like you can only use it this number of times before you pay, like we pay for tokens?
Yeah, I don't actually know much about this. Can you provide a little bit of context? Maybe you can explain it a bit. Yeah, happy to.
Oh, just like the theory that most enterprise software has been selling, per seat. So like if you had 10,000 employees, you'd have 10,000 versions. But then it's like one AI agent could consume the resources of 1,000 people potentially. So like what I'm asking is, do we move to a pay per use model where everything kind of looks like how we sell tokens, even if they're not tokens?
Yeah, I think so. Yeah, I think token it's a better like metric, right? For like measuring, the usage, right? Instead of like per seat. I do have I don't have a lot of concrete ideas here though.
Maybe let's talk a bit about training these agents and models. Like, we talked a lot about evils. So what do you think like will be the future, right? So there is some tension in agent training, right? That like you're doing RL on real environments versus synthetic trajectories, basically. What do you think the field or like the most agentic models will look like in a year?
Like the training of those models, or
Yeah.
yeah, I think it will be still like a hybrid of both, right? Like synthetic data. I think one good source of like data is like the flywheel data, right? Where you roll out your product and then let like millions of users using it, right? And then let them sign agreement to kind of reuse some part of that data and try to push that into like SFT, right? And then you can keep updating your model and then release a new version to the users, and then users get like more powerful models, and then they're gonna use it to crack more difficult problems, and then you get like even higher quality trajectories, and then you can just uh, like the flywheel gonna rotate, right? And then your models are gonna improve. I think most of this happens for like SFT uh, data. Like for RL, it's still a little bit different, where because you need to you need to have like the actual environment, right? Because like the product data, mostly you don't have the environment. Let's just say cursor, right? So you kind of know like the entire chain of thoughts, and then like the files and grids, whatever. But you don't like the I yeah, I might be wrong. I don't think like Cursor has the entire like environment that users it's exposed to. Like for example, like all the libraries and all this like packages or whatever, right? So it's pretty hard for them to, or for the model providers to actually reconstruct the entire environment. and then use it for like RL training. So what they use mostly like this trajectory would be very appropriate for like the SFT. For RL, you probably still need to like have like all these synthetic environments and then simulated whatever, right? Simulated environments or whatever, and then try to do like a lot of rollout with that, and then try to teach the model to do interaction. So, but now even like the environment itself can be synthesized, right? The model, the more like agentic models, the powerful ones, they can also build like better environment, right? And then you can self interact with that environment. So you still get this like flywheel, right? Where you build better environments, you get like harder prompts, and then you get better reward, and then you train better models. And then this better model can produce a better environment, or even harder environments, or even more complex ones. And then you keep climb on top of that. So you can have like this flywheel to kind of make the model better and better. It's just
Do,
that this whole process takes a lot of time.
do you have opinions about the value of SFT and RLHF? Because traditionally we have the field say, okay, you do SFT first and then some variant of RLHF. But I always felt like, there's dozens of variants of all of these algorithms now. And do you sort of agree with the kind of meta game that we're in right now with how we're doing, I guess, post training?
Yeah, yeah. I think that's a very good question. I don't actually know a lot about how people deal with like SFT and RL in other frontier labs. And I think right now, I would guess people still have like these two phases of like doing like SFT and RL, mainly because like RL data is just harder to curate, and then it's like a lot more hackable there. So the like also the RL infra is pretty hard to build, all right? So people are still kind of using a lot of SFT. Uh, but I think I've heard a lot of arguments saying that we should just eliminate SFT and just have RL. But I don't know. I feel like that might be the eventual game. But at this point, just people are finding it really hard to just directly do that. Yeah.
Do you think like that Israel teaching models to reason, or like everything is already in the base model and just like you need to reveal it?
Yeah. Uh, I I think there was a common sense saying that like the major capability is actually in the base model, right? Through pre-training. Like what you are trying to optimize is just trying to make your pass at one be the same as like pass at k, right? It's just that some of the tasks you can reach pass at 16, some of the you can reach like pass at two, right? So depending on the nature of the task. But there are also some other counter arguments, right? I think from like Cursor, they released a report saying that like throughout their like large RL training, their parse at k also increases. It's not just a game of like matching your parse at one to parse at k, right? So I'm personally leaning towards the uh cursor's conclusion. I do think like RL can help the model discover some of the new capabilities, right? But it highly depends on what kind of capability that is, right? So, and then it also boils down into the evaluation itself, right? So, in terms of like, if you have like good evals, right, you kind of uh, give a pretty good signal in terms of like what kind of capability it cannot be hucard in RL. So, what kind of capability can be hucard in RL, right? So, I personally think like coding and probably like reasoning can be hucard in RL, something like knowledge and maybe some sort of like personalities or some sort of you know uh some kind of capabilities that cannot be improved in the RL. So I think it's a very complex uh, game here. It's like we don't have a very good conclusion at this point.
So if you had to point at like one specific capability, like where current agents are about to make kind of a step function jump in the next year, and one that they will still stock. What are they?
Yeah, because like I haven't used like measles, so I think that model is like more powerful. Some of my like my hypothesis might be wrong there, right? So I still feel like the current models are pretty like reluctant and less exploratory. And that basically it also correlates with like creativity, right? So in a lot of the cases where the models are kind of failing in some attempt, it's a reluctant or it that kind of declines to try other approaches or take a totally different route. It's kind of like overfitting towards some of the trajectories or some of uh, the strategies it's being exposed to in like the post training, right? So that's one issue that I've been seeing. So, for example, if like one command, if the model has been using one command, like git command or whatever, right, in the post training a lot, and then like in the real world scenarios where like the user try to deploy this agent, and it just happens that it doesn't have this command or it's a different like git version, and then the model sometimes get very upset and then realize that and then it cannot install that version, right? Because the model the user doesn't allow it to, and then the model can kind of give up. So I still encounter a lot of these cases. And then model tries to like memorize this and try to recall a lot of the skills from the previous training, and then somehow these skills are not aligned with the real environment, and then it's kind of reluctant to explore what's actually there in the environment. There might be some other tools or command that can give you exactly the same functionality. The model is not able to discover it or something like that. So I've seen this. I feel like this could be a very good area for the model to make progress. And there's also, I think, rather a clear recipe to climb on these capabilities, right? Because we can just very easily, build more environments or build like more diverse environment and then expose the model to like heavily different, like tool sets, whatever. And then the model kind of like help the model or gear the model towards like using diverse tool sets and diverse routes. So I think this is just a matter of time. As long as people curate enough data and environment, the skill will increase. So that's why I'm just trying to answer you. Like this is like a short-term thing. I think like next year or something, we will see a lot of progress being made in this kind of skill set.
And what problems will still be there, like in a year?
Yeah, Uh, I think security is probably the most important topic like in next year, where like our agents are becoming so powerful, but they are still making some mistakes, right? So as they are becoming more powerful, we are more uh, prone or we are more happy to like deploy it in more critical environments, right? We deploy it in like Uber Eats, maybe later on we deploy in our banking systems or deploying in our, like stock market, like our stock market, like softwares, right? To help us like invest, right? So we're trying to like expose the model to more and more risky scenarios. And then the model gets more privilege and more permissions, right? So the security becomes a huge problem there in terms of like, they can still make mistakes, right? And even like now, it's like even like 1% of the mistake can cause huge trouble, right? So how can we make it them like extremely trustworthy and understand like what kind of scenarios they need to like still offload this decision to humans and what kind of boundaries we set for the models to like to not do something, and we also wanted to be like resourceful, right, and do things, automate a lot of process, right? This boundary is pretty blurry at this point, and then yeah, I think moving forward to consider how we should kind of set it properly so that it can maximize productivity while also kind of decrease the risk. Yeah, we can deploy one would deploy it.
Okay. One last question. What's the paper or idea from the past year that like it's not your own that you think is undervalued, and people will look back on it and say like, oh, this is very important in retrospective.
Yeah.
Oh, just the paper you think is so cool.
Yeah, I think there are some like really cool papers coming out from. It's not just one paper. I love reading some of them, like coming from like DeepSeek and Kimi, right? They are pretty like brave to explore a lot of like architectural ideas, right? So the residual connection models and some others as well. I think they do provide a lot of like insights. I think people like when they look back, probably these things will be the next breakthrough for the model to make like huge progress. I think architecture wise, would be the ones to look at.
And is there any work that you're doing up for very soon, that you want to talk about, or especially on benchmarking?
Yeah. Uh, so specifically, ClawBench is something that we try to push a little bit further. So that's something we want to have like V2, V3, and so on and so forth. Right now, like the annotation of like ClawBench is very it's very slow, and then it's also like involves a lot of humans. So what we ended up doing is that we create this prompt and then provide it to like human annotators, and then they're gonna do these tasks on their browser, and then like they're gonna intercept and copy the last like HTTP request uh, copy the last HTTP request, and then they're gonna write the regular expression to intercept that or something like that. It's a pretty like slow process, and then we think about like how to let the agent even like, take this over, and then we try to build some like plugins, and then ask the model to explore the web, and then also intercept all these HTTP requests on user's browser, and then we also try to find the queries that can be less dangerous and can be more uh, and can be more focused on websites that don't have like a lot of this anti-bot detection system implemented, so that it can be more stable and more safe to use for the future, right? So right now, like ClawBench, is just like a attempt to kind of evaluate models' performance on this real production system, but still like very early version. There are lots of issues for that, and then we try to automate this process and try to make it like more stable and then less risky to use, so that it can become like a better benchmark for like measuring like models realistic capabilities on these production systems.
Okay. Sounds very interesting, and
Okay.
I'm sure that you will you will get it like, and it will be very exciting. Okay. Do you have anything that you want to add, that you want to advertise, that you want to sell?
Yeah, I don't think I have anything more. Yeah, thanks a lot for the interview. I learned a lot from you guys, and yeah, I think it's a very interactive and very happy discussion.
Thank you. Thank you so much for coming, and thank you for the audience. See you next time.
See you.